Greetings, Mr. Sutton, with the IM3 Honors 1-3 Extra Practice Number 2 solutions on piecewise functions. On this problem, we're graphing this piecewise function, which consists of two lines. The first line goes left forever and stops at -3, the x value -3. The second line is starting at -3 and then going to the right forever. So let's find the first endpoint, and then we'll work backwards to draw the rest of that first line. To get that first endpoint, we're going to plug our border value of -3 into this first rule. So we've got -3 plus 1. That's +3 plus 1, which is 4. So that means we have the point -3, 4. And because we have the equals on -3, that's going to be a solid dot. The function actually exists at this point. So looking at our graph here, -3, 4, that's right here, solid dot. Now I'm going to use the slope of this first function to get another point so I can sketch this thing going to the left. We have a slope of -1, that's what this negative x here is telling us. Now instead of going down 1 and right 1, which I would normally do, because we can't go right, we have to go left, I'm going to reverse both directions. I'm going to go up 1 and left 1. And that'll give me the same downward slope as I kind of look at this thing going from left to right. Now I can just draw a line going backwards with an arrow through those 2 points. So this is our first branch. For the second branch, we want to figure out the x and y value where this second rule is starting. So I will again plug in my border value of -3, but now I'm going to do that for the second function. So I'll have -3 plus 2 this time around. And this will give me my second start point now. That's going to be +3 plus 2, which is 5. So that's a different point. This is -3, 5 that this rule happens to start at. And there's no equals on the -3, so this is going to have to be an open dot at -3, 5, which is right up here. But now the slope is actually the same as before. We've got -1 for the slope. And now I can just do normal slope, go down 1, right 1, and draw a line through those. And this is my piecewise function. For this one, we're trying to graph the following piecewise function, which consists of a line up until you get to x equals 0. And then after that, there's also a line, but it's a horizontal line from 0 onwards. So let me draw the first part of this by figuring out where this first line ends, because I know it goes left forever. So I'm going to plug 0 into this first rule to see the first endpoint. So -2 times 0 minus 1. And doing this will give me a y value to go with this. And now let me just put a 2 there. I mean, in the long run, it's not going to make a difference, but just for the sake of showing my work and where things are coming from. So this is just going to be 0 minus 1, or just -1, which means the point 0, -1 is where this first line is ending. And since I said x is less than 0 with no equals there, there's no equals, that means this is an open dot. I'm putting it 0, -1. So here's 0, -1 right here, open dot. And now to figure out where I'm going as I move to the left, because this is a leftward moving function from this border value, I have to look at the slope of this line, which is -2, based off of mx plus b form. So that means I would normally be going down 2 and right 1, but since I'm going left, I'm instead going to go up 2 and left 1, just reverse both directions, and then draw a line going through those. Next, I'm going to draw this second rule here. Now, since I have a constant value for this one of -1, that means the y value is always -1. So the start point for this is just going to be 0, -1. And that's going to be a solid dot because I have the equals in my inequality. So 0, -1, which it just so happens is the exact endpoint of the first rule. Total coincidence, but we're going to fill in that open dot with a solid dot now, because now this point is actually part of the function. And we have a slope here of 0, horizontal line. So that means I'm just going to do a horizontal line going forward to the left, to the right here. So there we go. To graph this piecewise function, which consists of 3 lines, I'm going to do one line at a time. For my first line, I've got a horizontal line that goes horizontally until I get to this x value of -3. Then it just stops. To find that stopping point, if I just plug the x value -3 into this, I get back a y value of -4. Surprise, surprise, because it's a horizontal line. And because I don't have an equals on this -3 inequality right here, that means I have an open dot at -3 comma -4. So that's right here. And then, again, this is a horizontal line, slope of 0. So I'm just going left forever from this little spot in space that I just drew. So that's my first rule. The second rule is a horizontal line going from -3 to 2. And we have a y value of -2 for all of those values. So my first point on this one is going to be -3 comma -2. We have an equals here, so that's going to be a solid dot. So -3 comma -2 right there. And then my second point, if I plug 2 as an x value in here, I get back the point 2 comma -2. No equals on the 2, so that's going to be an open dot at 2 comma -2 right here. And then just connect those dots. Finally, we come to this last rule, which is not a horizontal line. But just like the other ones, let me plug in the border value here to see what point this thing is starting at. And then I'll get another point to draw it. So if I plug 2 in for x, I've got -2 plus 1, which is -1, which means I have the point 2 comma -1. The equals is in the inequality, so this is a solid dot at 2 comma -1. So we're going over 2, down 1, right there. And I need one more point to graph this. Since it's not a horizontal line, I have to do a little more work. To get that, I can just use the slope on this thing of -1. So just starting at the point I just drew, I'm going to go down 1, right 1 using that slope. And then I'll draw a line through those. And then we're done with this one. To graph this piecewise function, which consists of 3 horizontal lines, we're just going to go one line at a time. This first horizontal line is at the y value 3, and it goes until we get to the x value -4. So here's the x value -4. That means, since it's a horizontal line, I know automatically I've got the point -4 comma 3 on there. Since we have the equals on the inequality, that means that we're going to have a solid dot there. So -4 comma 3 right here, solid dot. Slope of 0, so we're just doing a horizontal line going to the left here. Next, I've got this middle rule that goes from -4 to 1. Since it's just a horizontal line that is always equal to -1, that means I've got the points -4 comma -1. No equals on either of these, so these are both solid dots. So -4 comma -1. And I've also got the point 1 comma -1, which is over here. Connect the dots. And last but not least, we have this horizontal line that's at 5 after we get to x equals 1. So we have the point 1 comma 5 to kind of start this thing off. Solid dot because we have the equals. So we're going, let's see, 1 comma 5 is all the way up here. Slope of 0. So let's just draw a horizontal line going right forever, and we'll call it a day on this one. For this problem, I've got a piecewise function with 3 different rules that I'm trying to graph. The good news is that each of these is a line, so it's fairly straightforward once you've got 1 or 2 points for these to graph each of them. The first line is a horizontal line, and it ends at -4 for the x value. It goes left forever. So I want to figure out the ending point for this first line, and then I'll work my way left to draw the rest of it. Now, if I plug in -4, the x value, to see the y value where this thing ends, this is a constant function of -3. So plugging in -4 just gives me -3 back, which means I have the ending point -4 comma -3 for that first line. Since we have equals with the -4 with the inequality, this is going to be a solid dot at -4 comma -3 right there. And again, we have a horizontal line, slope of 0, so I'm just going horizontally back to the left here. Next, I have this middle piece to draw. To get the starting and ending points for this, I'm just going to plug in -4 and 0 to this function. If I plug negative 4 in here to get the starting point, negative 4 plus 4 gives me 0. So that means I have the point negative 4 comma 0. Since we didn't include negative 4, there's no equals on that part of the inequality. This is an open dot at negative 4 comma 0. So negative 4 comma 0 right here. And it would have to be an open dot, otherwise you would be breaking the vertical line test here. Now to get the second point, we're going to plug in 0 to x plus 4. And plugging that in gives us 4. So that's the point 0 comma 4. We have an equals on that inequality, so that means we have a solid dot at 0 comma 4, which is all the way up here. And now I'll just draw a line connecting those. Finally, I have this third rule, which is also a line. To get the starting point for this, let me plug in 0 for x. That's going to give me, let's see, 0 minus 1, so just negative 1. So that's the point 0 comma negative 1. It's going to have to be an open dot because we already used up our solid dot on the last rule. So we have 0 comma negative 1 right here. And now I need one more point to graph this line. We have a slope of negative 2 on this rule using mx plus b form. So that means starting at this open dot, I can go down 2 and right 1 to get another point, and then just draw a line through those. To graph this piecewise function, I'm going to graph one rule at a time using kind of the starting and ending points for each of the rules. Now these are all lines, so I need at most 2 points to graph each of these different pieces. Looking at our first piece here, we have a constant function of 1. That's just a horizontal line along the y value 1, and that is going all the way until I get to negative 3. So that means my endpoint for this, just to kind of anchor it in space, is going to be the point negative 3 comma 1. Now we have an equals on this inequality, so this is going to be a solid dot at negative 3 comma 1, so that's going to be right here, solid dot. And since this is a horizontal line, slope of 0, we're just going to go left forever horizontally from there. Next, I have this middle rule here. I have to figure out kind of the starting and ending points for this middle rule. To do that, I'll plug in negative 3 and 1 and see what kind of y values I get back. So for the starting point for my second rule, I've got negative 2 times negative 3 minus 2, plugging in this leftmost x value for that rule. That's going to be 6 minus 2, which is 4. So that gives me the point negative 3 comma 4. And since we have no equals next to that negative 3, that means we have an open dot at the point negative 3 comma 4 up here. And now to get the other point for this piece, I'm going to plug 1 into that second rule. That gives me negative 2 minus 2, which is negative 4. No equals, so again we have an open dot, this time at the point 1 comma negative 4. So that's going to be all the way, let's see, here's 1, here's down 4, right there, open dot. And then we'll just connect the dots there with a line. Now we go to the third rule, which is just a horizontal line going at y equals negative 6. That's starting at the x value 1, so that's the point 1 comma negative 6 then. We have the equals, so that's going to be a solid dot at 1 comma negative 6 down here. And again, 0 slope horizontal line, so I just draw a horizontal line going to the right.